Hi everybody again. This is the final phase of density. We're working on two very similar objects that look to really have the same density, number one and number two, and if I were to pick, you couldn't pick one which would have a different density, right? So we found out that number one had a density of less than one, and did we take it over and put it in the water to see whether or not it floats? This should float because it has a density of less than one. Remember, water has a density of one, so let's see if it floats. Oh, I'll be dang. Look at that. It floats. Could be a boat, right? Floats right on top of the water. Has a density of less than one, so it floats. So there that is. Not bad. Okay, so that theory's proven out, hasn't it? So back over here to my handy dandy desk. Now we're going to take a look at, number two. Number two feels a little bit different. Okay, now it does have the same volume because we just tried it just a second ago with others. Yep, it has 9.5 is the height, and it's got 7 is the diameter, which we take in half of the radius is half the diameter, and we did it so it has the same volume. It has the volume of 365.4 centimeters cubed. Now the critical thing is, does it have the same mass? Okay, because that's the deal breaker there, isn't it, when two things look exactly alike. So let's take a look at this. The other one had a mass of, what was it? Mass of 55.4 grams. And then we divided that by the volume of 365.4, and we got less than 0.15 grams for number one. So let's take a look at number two. And wow, it looks like it's going to be a lot more than 55, isn't it? So it is 426.8 grams. 426.8 grams. It's hard to write while you're holding this thing. Sorry. So 426.8 grams. So now the density is equal to, mass divided by volume. So density is equal to, in this case, 426.8 divided by 365.4 centimeters cubed. And now we're going to divide that out, see if is that higher than one? Sure it is. So got to do that. So turn that on. So we got 426.8 divided by 365.4. And it's 1.1, I'm going to round up the hundredths, so 1.17 grams per cubic centimeter. Okay, so in our theory, this baby should sink. So it has a lot more mass. It's heavier. Yeah, you can feel it. So is it going to float or is it going to sink? Let's see. Going to apply the ultimate test to our theory, and let's go. Let's see, here's the one that floats. Yeah, that's floating. Will that sink? Yeah, boy, it sank like a rock, didn't it? Went right down to the bottom. Went right down to the bottom. It's heavier than 1.0. It would have kept on going if there was, had to be a bottom to the sink. So one floated and one sank. This guy was under 1.0, which is the density of water, and this guy was over 1.0, which is the density of water. This guy is 1 point something, and it sank. Pretty interesting, isn't it? So density is one of those real magical tools that we as scientists and engineers and in construction, I'm going to take the water out of here. Had that in there for a while. In construction and things like that, when they talk about density, making automobiles and the like, and just having something that you know is pretty consistent. Let me take these back over here. And having something that's works, actually does work in the theory of science, and that's how that goes. Anyway, that ends our lecture and labs on density. That was pretty interesting, I thought. Okay, talk to you soon. Hope everything's okay. Bye.